Hello everyone, we are now beginning example 2 and 3, which are on finding the inverse equation. So now we're only focusing on the equation of the original function or relation and then the equation or relation of the inverse. So when we start this, now the first thing we're going to do, we're going to be changing our function notation f of x into a y equals equation. Okay, so f of x is the same thing as a y. Okay, I technically could put a y there. So, and this will make sense in a little bit. So I'm going to replace my f of x with a y. So it's going to be y equals 2x plus 3 over 4. So, just like we did in example problem 1, okay, to find the inverse of a relation or function, the x and y must interchange. So my x and my y trade spots for the day. My y is going to hop to where the x is, and my x is going to hop to where the y is. Okay, so the first step when you're finding your inverse equation is to interchange the x and the y value. So we're going to move on to our inverse equation. Alright, so if my x hops to where the y is, my equation's now going to be an x equals equation. Okay, and now all that's going to happen is my my x is going to transform into a y. So I'm going to rewrite the same side of my equation just as it is, except the x is going to turn into a y. It's going to be magical. So it's going to be 2. Now my x will become a y plus 3 over 4. Alright, and then from here, all you have to do is to solve for y. So we need to get y on one side by itself. So currently all this stuff is getting in the way. The 4, the 3, and the 2. So eventually we're going to need to move things to the other side. Now, whenever you have a fraction in an equation, personally what I think is the easiest thing to do when you're solving is to do cross multiplication. So, what I personally like to do, you don't have to do it this way, but this is the way I like to do it. I like to write both sides as a fraction. So another way to write x as a fraction is x over 1. And then what we're going to do is we're going to be cross multiplying. Okay, now you can only cross multiply if there is an equal sign. Okay, the demon cats will get you. When you multiply two fractions, you do not cross multiply. Be careful. Okay, only if there's an equal sign can you cross multiply. Okay, so when I cross it, I'm going to start, since usually we write y equals first, I'm going to start with the y part first. So 1 times 2y plus 3, well 1 times anything is itself. So 1 times 2y plus 3 is going to be a 2y plus 3. I'll write it in blue. Equals, and then when I cross the other way, 4 times x will give me a 4x. So now our fractions have disappeared, and although our fractions are our friends, okay, sometimes it's easier to solve when we don't have a fraction. So I've eliminated the fractions, and now I'm just going to get y on one side by itself, and then we will have solved for the inverse equation. Alright, so the first thing we need to do, this 3 is currently getting in the way, so we need to move it to the other side. So the opposite of positive 3 is negative 3. So I'm going to subtract this thing on both sides. Okay, which I can't combine these because they are not like terms, so I'm just going to leave it as 4x minus 3. So now I have 2y equals 4x minus a 3. Alright, and we only have one more step, so the last thing to get y by itself, that 2 is currently getting in the way. Okay, and since 2 is secretly multiplying to the y, it secretly is, okay, the way we move that to the other side is through division. So I'm going to divide both sides by 2. And I'm just going to leave that whole thing just like that. You don't even have to reduce it down. We're just going to leave it just like that. Okay, so on this side, my 2's are going to cancel out. Bam! Okay, so I'm left with y. I'm going to go up here. Y equals 4x minus 3 over 2. Okay, and the very last step, so we have found the inverse. This is our inverse equation. Okay, but we started with function notation, which is the f of x, so I would like to end with function notation. Okay, so the way that we denote that something is an inverse using function notation is like this. Okay, when you have this little negative 1 hanging out with the f right here, that means the inverse of f of x. Okay, this does not mean f raised to the negative 1 power times x. That does not mean that at all. All that means is this is the inverse of f of x. That's all it means. Okay, so the inverse of f of x is equal to 4x minus 3 all over 2. Holy hot dog, we're done with that one. Yay! That is our inverse equation. Awesome. Yay! Alright, and then for example 3, now this is the same thing as we did before, so if you think you understood that pretty well, okay, if you want to try to do this one on your own, you can, and fast forward to the end and check yourself when you get done. Okay, so example 3. So, like before, remember we said that our f of x can be rewritten as a y, okay, which it kind of makes sense to change it to a y when we do inverse functions. So I'm going to rewrite f of x as a y equals 2x squared minus 4. Now remember from the previous problem that we just did, to find the inverse, what we have to do is interchange, that's the fancy word we keep using, interchange our x and our y. So my x is going to hop to where y is, and my y is going to hop to where x is. So moving on to our inverse function. So if my x hops to where the y is, that y is going to transform into an x. Okay, and I'm going to write my 2, and I've spotted an x, so that x is going to transform into a y. Everything else stays the same, so I'm going to keep my squared and my minus 4. Okay, so the only thing that changes is y turns into an x, and an x turns into a y. And after that, all you have to do is solve for y, and then you're done. So let's get going, you guys. I'm super pumped up. So, first thing, okay, when we're trying to get y by itself, now I personally like to write the y first, so I'm just going to rewrite this with the y on this side. It's personal preference. These two mean the same thing. Okay, so I just kind of flip-flopped my equation. It's called the symmetrical property. But anyways, this makes it so my y is on the left-hand side, which I prefer to be on that side. Alright, so let's start solving. So, when I'm solving for my y, currently that negative 4 is getting in the way, and the way that we move that bad boy over, the opposite of negative 4 is a positive 4. Okay, so we're going to add it on both sides, and I cannot combine these since they are not like terms. So I'm just going to leave it as x plus 4 on that side. So this is going to be 2y squared equals x plus 4. Alright, so now, next step, that 2 is getting in the way, and since 2 is secretly multiplying to the y, okay, the way we move that over, the opposite of multiplication, is division, and you divide the entire side, Okay, and like last time, I'm just going to leave it looking like that. We don't have to reduce things down. Okay, so my 2's cancel out, so that leaves me with a y squared equals x plus 4 all over 2. Alright, now, we're so close to being done. We're so close to solving for y, but this squared is getting in the way. Okay, now, we have to think about what is the inverse or the opposite of a squared. Well, the opposite of squaring something is square rooting something. So the way that you cancel out a squared is to take a square root. But you gotta square root both sides. So square root that thing on both sides like that. Okay, if you do it to one side, you gotta do it to the other. And when you square root a fraction, you have to square root the whole thing. So my denominator and numerator are both underneath my square root. Okay, so what that does, it cancels out my squared. So the square root cancels out the squared. Okay, so on the other side, we'll talk about one more thing that's going to happen when you square root both sides. So now I'm left with a y equals, we have our square root of x plus 4 over 2. Now, whenever you square root both sides of an equation, a plus or minus is going to pop up. Now, the reason why that is, I'm going to give you an example to kind of explain why there's a plus or minus. So, this is kind of a little side note. Doesn't really involve the problem, but it kind of explains that plus or minus. If I have x squared equals 9, okay, there are two possible numbers that I can square to get 9. I could square a positive 3 to get 9, and I technically can square a negative 3 to get 9. 3 times 3 gives me 9, and negative 3 times negative 3 will also give me a 9. Holy hot dog, right? So both positive numbers and negative numbers, when you square them, will give you the same answer. Isn't that cool? Okay, so that's why we have a plus or minus as an answer. So if I was solving this one and I had to square root both sides to solve for x, my answer would be x equals positive 3 and negative 3. Okay, you can read that as a negative 3 by itself. Okay, I could kind of take away the plus 3. So that's negative 3 or positive 3. That's kind of how you interpret a plus or minus sign. It's one or the other. Okay, so every single time you square root both sides of an equation, there must be an equal sign. A plus or minus must pop up, always. Okay, we square rooted both sides here, so a plus or minus had to pop up. Okay, so we have one more step to get this thing into our function notation. So this is the inverse equation, but I want to write it using function notation. So if you remember from the previous problem, that fancy way to write the inverse is f negative 1 of x, which all that means is the inverse of f of x. So the inverse of f of x will equal plus or minus, don't forget it, the square root of x plus 4 over 2. Bam! Just like that. And that's our inverse equation. I had fun, you guys.